So it's 10:30, so we are starting the next session here. So this is the first session in our mini symposia about tooling, which is basically everything that we use to write Julia code or to deploy Julia code and these things around. So that's organized by Team Holy and Claire Foster, who couldn't be here unfortunately, and myself. And we will occupy this room for the entirety of the day, actually. So, all right. So first, let me introduce the first speaker, where we'll present a new linter. So the floor is yours.
Thank you. Hi, my name is Alexandre Bergel, and I work for the company Relational AI. And I live in Bern in Switzerland. And this is my very first JuliaCon, and I'm super happy to be here. Like, I see all these famous names. I'm very happy. So ReLint. So ReLint is a new lint checker for Julia. So lint checker is a tool to improve the quality of Julia source code. Like most of the programming languages, they come with at least one lint checkers. And lint checkers, you know, like if you write just a few lines of code per day, then probably you don't need to worry about using a lint checker. But as soon as you have a large amount of code, as we do, then lint checker is very important. Like our software is slowly, you know, heading toward 1 million lines of code of Julia code. So it's very important to use lint checker to control the quality of some aspect of our code base. You know, a lint checker could be useful in many different ways. You know, for example, it can help you, it can help new Julia programmers to avoid some mistakes. Also, like, can help one forbid some particular construct, you know, Julia keywords or Julia API that you don't want to use. Also, like, you can enforce some corporate programming conventions, something very important as soon as you have, you know, a sizable amount of software engineers working on the same code base. Also, like, you can enforce some architectural invariant. You know, imagine that you have your software that is made of a number of components. You may want to prohibit, you know, one component accessing the API of other components. You know, let's say the core of your application must not refer to the test, but the other way around. And also, like, you can enforce some security policies, and I will give an example about that. So lint checker, a lint checker usually works by thoroughly looking at the source code. No matter whether your application can be compiled and run, you just look at the source code. So ReLint. So ReLint is a new lint checker that we design. It is distributed under the MIT license. So we are a company, and we think this is a very good idea to have ReLint open source. So ReLint started as a fork of static lint. So at first we used static lint, and we were happy, but up to a point. And I will explain about that later. And if there are some of you who are involved in design of static lint, then thank you very much. I learned a lot. ReLint is small and fast. The core of ReLint is about like 700 lines of code, and it is fast. So we run all our rules on our 700K lines of code of Julia code in less than 3 minutes. And usually, like, if you're just doing some incremental modification on a few files, then this is just very fast. And also ReLint is with ReLint, it's very easy to design and add new rules, and something which is very important to us. And also ReLint can be embedded in a GitHub Action workflow and also a pre-commit. So, and ReLint works by doing some pattern matching on the AST, the abstract syntax tree. So the abstract syntax tree, one example here, if you use the CST parser as we do and as static lint does, then you can have CST parser.parse, and here you have some Julia code as a string. And then the result of the parsing is just a tree. And then we do some pattern matching on that tree. For example, here, actually those 2 lines are some real tests of our test suite. You know, here you have this meta variable, whole variable, that can matches anything. In that case, the whole variable matches the 5 here, or the whole variable can matches the 5 plus 10. And that's really the essence of ReLint. Okay, so you define some patterns, and those patterns ReLint will look for instances of those patterns in your code, in your source code, and then you can define the rules accordingly. So I will give you like 4 examples of some of the rules that we design, non-trivial rules. So about task scheduling, you know, in Julia there is a number of ways you can achieve concurrency. For example, you can use @async, which takes an expression and run that expression in the same thread than its parent. or you can use spawn, add spawn. And again, it takes an expression and it runs this expression in any available thread. Both async and add spawn provide concurrency, but async does not provide parallelism, whereas add spawn provide parallelism. So we, as a company, we took the decision to forbid the use of add async in our code base to favor add spawn. So how can you use ReLint to enforce this rule here? You define here a subtype of violation lint rule, it's called async lint, and then you define this function here, check. And this function check takes x as a parameter, which is really the portion of the AST where ReLint is checking your code. And then if there is an instance of that pattern async whole variable, then it will just return the error message. Then for this rule here, we have two checks. The first is at async and threads at async. And then here you can, an example on how to run ReLint. Then you see ReLint.runLint on text, and here you have some Julia code, and then you will have, you will have here an error saying that line 1, you should use add spawn instead of add async. So this is just one way to run ReLint. There is many different ways. Usually you just run ReLint on a folder, which is the root of your application, and will look for all the Julia files. As a second example here, I want to talk about the Julia compilation. So Julia compilation may be significantly slow, and that could be really a significant issue. Again, if you just have a few hundred lines of code, this may not matter. But as soon as your software is very large, as we do, and especially when you use the types in a very exotic ways, then Julia compilation can really be a burden. Thanks, there is this package compiler.gl, which is very useful. It speeds up the Julia apps by avoiding some just-in-time compilation. And the idea of package compiler is that it serializes all the compiled elements into a file. So there is two phases. There is these build phases where you run your application in order to identify, in order to compile things and store everything that's being compiled into the file. And then you run your application in a normal way where it will benefit from the previous compilation. And that's really great. Package compiler actually also serialize all the compiled elements into a file and the functions, but also the value of constant variables. They are serialized. So it means that if you have a line such as const threads count equal threads and thread, which is in order to know how many threads are there available, then using package compiler, I mean that you can have the expression being run on the machine where the program is built, which could be a very different machine from the machine where you will run your application. So the thing is, so you don't want to run your application with the value of n threads coming from the machine where you build it. So how to forbid the use of threads and thread in a constant variable? So again, you define a subtype of violation lint rule, initialized with function rule, and here you have this check. The difference with the previous rule here is that you want this rule to be checked only when you are in a const, top-level statement. And this is what here we have. We have this marker saying that, if you are in a const, if I'm not in a const statement, then I just return. Then if I am, then I just evaluate these checks here. Then I say, if I found instances of threads and thread, then I will display that message. Same thing for isLocalDeployment or deployment.isLocalDeployment. As a third rule, consider this code here. If you have if foo and do something, else if foo do something else, I mean, obviously this code is, is not correct. I mean, you can't have twice the same condition for two different branches. I mean, assuming, and this is a reasonable assumption that foo doesn't do any side effect, then this code is really weird. And that looks obvious here, but if the two foo condition here are a couple of hundred lines of code away, then it may be hard to spot that. So you can define a new rule here saying, if whole variable a, so here I did this a here, whole variable else if whole variable a, it means that the content here must be the same, because there is this small here label that comes next to the whole variable. It means that there is a constraint between these two conditions, they must be the same. If this is the case, then we just here display this message, unreachable branch. And as the last example about security. So like relying on external logging facilities is, like this is very difficult. I mean, you must be very careful with what you can log and what you cannot log. And like this is such, like an important problem that we design a facility for that. We design a framework called safe logging, and safe logging is really like to prevent data leaks in the log. And it's very simple to use, and it was designed that way. Consider here this example. You have the struct users with the username and the password. And here I create a user, my name and here the password. Obviously, this password is sensitive and must not be logged. So the way we can use our framework, safe logging, then you define here a safe show. Safe show here takes an IO and a user, and then here write in that IO saying, oh, it's safe to write users, it is safe to write the username, and here it is safe to write some asterisks. And then you can use the safe show like that way. You have arrobas info, arrobas safe, created users, and here we, the safe is aware of the interpolation here, and then we'll make sure that this thing is safe to be interpolated. And here you have an argument, username also has to be safe. And then whenever you execute that, then you see that there is no sensitive information being logged. However, nothing prevents you from, doing arrobas info user1, where here you will have this, this sensitive information being logged. And we don't want that at all. And how can you prohibit unsafe logging? Well, I mean, you write a rule. So I won't go into details. This is a more complex rule, but the idea is, again, you create a new type, subtype of, in that case, fatal lint rule. So fatal lint rule means that if there are instances of that rule, then it will prevent the pull request from being merged. Something very important. I will discuss about that later. But yeah, and the idea is if I am, like, again, that rule, the rule that checks for unsafe logs is very important for our code base, but if I am in a test, the test suite, or if I am in a benchmark, then it is totally fine to have unsafe logs. But outside those, tests and the benchmarks, we must prohibit unsafe logs. And here we say, if X, again, X, this is the AST that I'm currently checking. If this is a macro call and the name of the macro call begins with arrobas info, then if all the arguments are safe, then that's fine, else I report the error. So I gave you like 4 examples of some rules, but we have many more. So we have 33 rules like today, and those rules are categorized in 3 categories. So first here, we can have a recommendation rule. It means that if there are instances of that rule, then this rule will be reported to the person who will review a pull request. If there is a violation, then this will be reported and intended to be read by the author of the pull request. And the author must act on it. And then the fatal violation lint, this is again a violation that will, if there are instances, it will prevent the pull request from being merged. Again, this is all, we decided that we must not want to have anything that goes against some very strong rules. Okay, so that's the idea of the way that ReLint works. And ReLint can be embedded in CI/CD. For example, this is an example of a command that is being posted in a pull request on GitHub. And the idea is each time there is a commit being done, then you have ReLint that works and analyzes the file that has been modified and then give a report. In that case, there are 2 violations. Here that says, please use tin instead of Julia's in, or use T as key instead of Julia's as key. Tin and ASCII, those are some functions that we define, and we want them to replace the standard standard in and ASCII. And you can click here, and boom, it jumps on the on the on where the instances of that pattern was found. And here we have an instance of a recommendation that is good for the people who want to review the PR. Saying, at inbounds, should be used with extreme caution, since it can lead to some unwanted way. And also, ReLint can be embedded in a pre-commit. So here, this is an example of piece of code that I wrote. So here I have my code, and here I added this arrobas info, not at info, iterating over nodes, and kv, 2 value here. So if I try to commit that change here, just this new line here, the commit will be prevented. Like, I cannot commit locally on my machine. And instead, I will get this error here saying that at line 40, I have unsafe log statement. So this is an example of the rule I showed you before. So pre-commit is very interesting in that case because Lint is run locally and not on the CI/CD. And that could be very important because running on CI/CD, like all, it takes time and money, but locally is very cheap. And since ReLint is fast, then we can have those checks, being done like at no cost. So you don't even notice that things are being run. ReLint is easy to install. Obviously you can clone ReLint and from the command line saying, oh, I want to use ReLint on that folder here that is the root of my application. Obviously you can do that, but also you can create a GitHub action workflow and that's very easy. So you just create here this workflow and whenever you commit, boom, you will have this workflow being run and then the command being posted nicely as a command pull request. Okay, so as I mentioned before, ReLint has been inspired by static lint, so it's heavily inspired. At the very beginning, we used static lint, and we tried to extend it, and by adding a rule, and that was going okay, but up to a point where, okay, now we need to think a bit better. Static lint does not really, easily allow for new rules to be added. It was very cumbersome, and also it cannot be easily embedded outside VS Code. And for us, that was two very important aspects. So ReLint is designed to address these two issues, and that works nicely. On the other hand, ReLint does not really interact with VS Code, obviously. It could, but we haven't really made that a priority for us right now. Okay, I discussed with some of you about ReLint, and you guys gave me nice feedbacks. Maybe I can consider to use Julia syntax or Julia lowering or Julia server. That would be fantastic, and I'm very happy to be able to discuss that further. Things that I'm dreaming about is having ReLint to identify unused variables, unused functions. In the 700,000 lines of code of Julia code we have, probably there is dead code. And it would be great to be able to spot them. Also spotting typos, it happens all the time, and and it would be nice to have Lint catching those things. Also exploring the type inference, also something we would like to use. At some point, we've been using Jet, but we've been a bit unhappy with Jet. Again, I would be happy to discuss about that. And so that's why I think Julia syntax and Julia lowering really gives very nice opportunity. So I think also ReLint, if you no go on the website, I think it can be better packaged because currently ReLint comes with all specific and own rules, and if you want to use ReLint, and maybe you are not interested in all rule, so maybe we should split that away. That's just a small matter of programming, and yeah. So to conclude, ReLint is a lint checker for Julia, inspired by static lint. ReLint is distributed under the Mighty license, so I mean that you can use it. You can use it even for whether you are a researcher or whether you are a company. You can just use it. Maybe send me an email about we are using Lint, and I would be super happy about that. And new rules also can be easily added. They can be added without touching the core of ReLint. Can be added. New rules can be added in a separate file and in a nice way. So ReLint works well. It is currently being run roughly 100 times per day on a 700K log code base. Feel free to reach me if you want to try it on your code. We can just sit down and I will be happy to. So thank you very much.
Okay, thank you. Do we have any questions to the speaker? Yeah.
Thanks for a nice talk. Since many tools in Julia are, both, written by their users, so that gives one sometimes an interesting experience in that when one wants to write a new, I imagine when you write a new rule, if you discovered that ReLint isn't yet set up really to support that kind of checking, you just extend ReLint, right? So what's your experience with what fraction of the time when you want to do something, can you just target the existing set of checks with the specific thing you're wanting to look for versus you need to, right? I mean, the number of things I could imagine wanting to check a code base for are very large, right? And so the question really is having essentially a sort of a finite API for doing that, does that actually cover most of your practical needs for it?
Kind of. So for example, like if I look at this piece of code here, so this is here the example of thread that must not be used in a const statement. Here, like, how do I know that I am within a const statement? And here I use these markers. And I think using those markers is a kind of a hack. In principle, like if I would have very nice regular expression, library that works on the tree, probably I won't need those markers. But I'm not expert in regular expression. Like I never wrote a regular expression engine, and that would be something that would be really nice to have. And currently, like if you would have a full support of regular expression on the tree, then probably we would be better, like be able to handle some complex scenarios. But yeah. So to answer your question, so far it has been working very well. And the time we took actually was more like which kind of rules do we want to have as a recommendation or as a violation, or but we really spent a lot of time on that, not so much on building rules. And actually we had also some of our users, some of our engineers who have worked on writing new rules. So it seemed to be very easy to write rules, and well, we are happy about that. But again, this could be improved a lot, I think.
Right, anyone else?
Yeah, when you do this matching in your, what was it called? When you define a rule, you have this match. Is that your own code running the matching, or there's some other packages like macro tools that you can also match expressions in Julia with? Or have you written your own to do that matching?
No, I've wrote my own. I tried to use some external libraries, but it didn't really work out that way. Maybe I didn't look at the proper way, but no, we wrote it yourself. Actually, like the AST given by CST parser is really like clean and very small, so it was not that difficult actually to create, something that compares ASTs.
Okay, thank you.
Hi, thanks for the talk. I'm curious about the interaction with pre-commit, because in my experience with the formatter, it takes a long time to recompile every time your function of the formatting. So pre-commit takes a lot of time when you write Julia hooks. So did you find a solution for this, or do you need to compile all your functions on your specific code every time you're making a commit?
It is true that pre-commit can take time, but in our case, like ReLint is small, so just running, like to have pre-commit run ReLint is very, like it's fast. And so like I did some measurement, like it takes like about 1 second. You often, like if you just change a couple of lines, couple of files in VS Code, then running like pre-commit runs in about like 1 second, between 1 and 2 seconds, and give a report, and which is acceptable for us. I mean, we had this informal thread, limit of 5 seconds. We don't want pre-commit to take more than 5 seconds, but we are currently like well below this 5 seconds, and yeah.
Are you planning on making like a composite GitHub action so that people don't have to kind of copy and paste that GitHub workflow you have?
Yes, that's the idea. Like, yeah, I mean, we can sit down and we can try out. I would be happy to.
For example, in that threads.and threads example showed, is the pattern matching purely based on names or bindings, or does it also take into account, for example, where the threads binding stems from? Is it like the thread that's rendered with base, or some other module that just happens to be named threads and has an and threads function?
Now, like currently, we are not doing any name resolution, symbol resolution, and this is something I would be really happy to have. Now, currently, this is just on the pure names, just on the names, and yeah, but we would like to go further, which is why this Julia syntax and Julia lowering really seems to be very interesting.
Okay, thanks.
Thank you.
Okay, we have time for one more question, perhaps. Okay, I have a question. So you mentioned that it currently doesn't integrate with the VS Code, but of course most people use NeoVim. So is there a way to export these violations as, for example, JSON? Because if there is, then it's very easy to just parse it and display it in the editor.
Yes, yes, that should be easy to do so. Actually, we are doing that. We are doing that. So there is several exporters of the report. You know, you can have the report as a markdown, as you can have here, like for whenever it is used, you know, on CI/CD. Also, you can have a pure text file. Also, you can have the JSON. And the JSON, for example, it is no, it is not JSON. We have a dedicated exporter for the report by being used that on, you know, to annotate the PR using on GitHub. You know, like if you click here, then it will jump on the page, and then you have things get highlighted. And just to have that, we had several exporters. So yeah, that should be trivial to have a new one.
Then let's thank the speaker again.
Thank you very much.